Alright, hello everyone, and welcome to Chapter 4, Quiz 1 Study Guide. So for honors, you're going to be taking this on Thursday, which is, what day is that? The 13th. For scholars, you'll be taking this the next day on the 14th. For scholars, we're going through just a little bit less. What we're going to be going through we'll eventually include everything else the scholars or the honors class is going through. We're just going a little bit faster with honors because there's a lot more. There's stuff that we're gonna get to with just honors. So we gotta go just a little bit faster. Um, so few things. Um, a lot of what you're gonna see on this quiz is really gonna mirror what we did in class on Tuesday. And it's really just answering these questions. So I have the study guide, but a lot of this kind of mirrors the activity that we did on Tuesday. Um, so that's, I want to really, mirror that, and I hope you're paying attention. All right. So what I'm going to do really is just kind of go through an example of what we did on Tuesday, because that's basically what these questions are asking for. I'll stop for the purposes of this video. I don't want to record two videos. This document is for the honors class. The scholars, you will have a shorter study guide, and you won't have some of these questions. I'll tell you when what I expect from you. All right, so just want to make that clear. All right, without further ado, what we're going to be doing is similar to what we did on Tuesday. I'm going to give you an element. Let's take phosphorus as our element right here. And I'm going to have you just, answer a few questions about it. Alright, so the first thing, group of phosphorus. Here's phosphorus. Group is our vertical columns. We're in group 15. Here's phosphorus. Oh, circle phosphorus because we're going to be using it. Group 15, period, 3. Alright, nice and easy. Alright, what do all elements in this group have in common? So, there's two correct answers. The first is that they all have the same amount of valence electrons. They have the same amount of valence electrons. That's one of them. All of these elements will have 5 valence electrons in this group, which we can get from taking the 15. We subtract 10. We get to 5 valence electrons. The other thing is that they will have the same highest orbital. And what I mean by this, I'm going to go to electrons over here. If we look at nitrogen over here, nitrogen, its electron configuration is 2p3, right? And I'm going to show the blocks here actually. Why is this not? If we show our blocks, there we go. Get our colors back. Here is our 1s, our 2s, our 2p, our 3s, our 3p. Alright, so nitrogen here will be 2p2. Or, sorry, 3. I'm gonna just clear this out. 1s, 2s, 2p, 3s, 3p. Here's nitrogen. We'll have 1, 2, 3. We will have 2p3. Alright. Phosphorus over here. We'll have 1, 2, 3. We'll have 3p3. Alright, so when I say that all of the elements in the group, they will also all end with a p3 electron configuration. Alright, that's what I kind of mean by that. They'll all kind of end like that. Arsenic down here would have, here's our 4s, our 3d, and our 4p. So this would have 4p3. And this and the valence electrons, those go hand in hand. Alright, so they're both true, and they both, lead to the same results. Alright, what do all elements in this period have? Here is phosphorus. They are all... So, what this means is oh my god, I can spell. Their valence shell is n equals 3. Right? So everything in the same period will have a valence shell of n equals 3. And this is important, the way I'm wording this specifically, because when you get to n equals 4, right? If we look at the electron configuration for gallium, just as an example, we're going to get this. And these 3d electrons are not included in our valence shell. It's only n equals 4, which, as we can see, is the period of 4, period 4. So the valence electrons are only the electrons that are in the same principal quantum number, the same period as whatever element we're looking at. Alright, what is its electron configuration? So here is phosphorus. Phosphorus has 15 electrons. So we're going to start filling this up, and I can show you this here. Just to show us here. This kind of does it for us. But it's 1s, 2s, 3s, these are 2p. So you could do it this way. I'm probably not going to give you the orders on the quiz, because I want you to kind of go through it like this. Here's our 1s, here's our 2s, here's our 2p, here's our 3s, and here's our 3p, right? So we know we have 1s2, moving on up, 2s2, 2p6, 3s2, and then 1, 2, 3, 3p6. So here is our entire electron configuration. So let me type this out. Alright. Okay. So, oh, that's not 6. I am making mistakes. Sorry about that. I just correcting my own mistake. Oops. At least I'm catching it. That's good. 3p3. There is our electron configuration. Alright, so our noble gas configuration. So I'm going to erase some of this just to clear things up. Okay. So our noble gas, if we take phosphorus, we go to neon. That's our noble gas, which means that everything else up here we don't care about, which corresponds with all these electrons. So we only care about, to get the noble gas configuration, you only take the electrons that are in the same period as our element. Phosphorus is in period 3, so we only care about our 3s and our 3p. We do have to take neon here, take the noble gas that is above, in the period above our element, and then we just fill out 3s2, 3p3. Alright. Then, and I shoot these live, which is why I make mistakes, and I'm not a professional YouTuber, so that's why I'm not going back to edit. Alright. So that is our noble gas configuration. How many valence electrons does phosphorus have? Well, pretty simple here. Here is our electrons that are in our valence shell. We have 2 plus 3 equals 5. And I actually, when I went through, I did this the other way. We're in column 15, subtract 10, you will get to 5 as well. Alright, 5 valence electrons. So, our Lewis dot structure, all we have to do for this, we take our element, here is B. We start circling around the electrons. You know what? I'm going to do this over here, where there's space. We have 5 valence electrons. 1, 2, 3, 4, and 5. The reason that we do it in this kind of order, we're going to get to that. Just bear with me. It will make sense a little bit. So there is our Lewis dot structure. We're going to put this in here. There we go. Alright, that is all that I'm going to ask for scholars. We're going to get to the other parts of this, you know, throughout the next week. So probably on, starting on Tuesday when we get back, we're going to get to the rest of this. I'm just, you know, I'm a day ahead with the honors because we didn't have the schedule craziness, and I'm going to move a little bit faster because we do have a little bit extra to get through. All right. So that's all for scholars. I'm gonna continue on with our honors. All right. How many electrons will it gain to lose to, or gain or lose to fill its octet? Well, we have 5, and it's easier to get from 5 to 8 than to lose the 5 electrons, right? So we have 5. You could either lose 5 or gain 3. Gaining 3 takes less energy. All right. So 1, 2, 3, 4, or we add 3, so we are going to gain 3 electrons. If we gain 3 electrons, phosphorus has 15 protons. So if we're gaining 3, we have 18 electrons. And our charge is going to be 15 plus negative 18, which will give us a negative 3 charge. Alright, so our charge will form, we have a negative 3 charge, we will form a phosphorus 3 minus anion. Alright, and we're going to see why this is going to be useful for, you know, after our test. So that's really kind of it. Not that much with this chapter. It's just kind of been readjusting. We lost a day, we had a half day. Things are wacky right now. Alright, so that's all for this study guide. I will see you in class.